Well, hi again. Last time I was talking on the background information of the content we are going to see, and uh, I basically told you the main idea behind the demand and supply model, and basically, actually, the main mechanism, although we will see it um, uh, in a more detailed way, is actually simple. You can even see it here. The main mechanism that is bringing demand and supply together, the quantity that buyers demand and quantity buyers sellers supply to the same level, is the price level. So the price level is decreasing and increasing in a way that it brings those two quantities together. And as I said, in order to show this law, a model is created, mathematical model is created later, which is modeling the buyers and the demand and supply, how they are related to the how quantity demanded and supply is related to the price, um, basically. So later, and this model is used for different purposes, and one of those purposes was, as I said, measuring how efficient the market is, how much benefit it produces. Although that aspect of this model, I mean, that later development is challenged a lot, unlike the core model itself. And it is used also for further purposes. It is also used, for example, to see the how much the demand or supply is sensitive to price. I mean, if you change price a little bit, how much the quantity demand or quantity supply change. And this is an important, very, very important information for companies that are in the market. However, we are not going into those details, but if you are interested, you can look to the price elasticity um, topic, basically, which is, you can find it in your book. Anyway, and it's also used to analyze some state policies. We will use this model to look upon one particular state policy in the second part, which is the price controls. I mean, setting a minimum price or maximum price people need to pay or accept in a market, particularly, which is done in the mass market also, by the way. In some countries, I mean, the countries fix the price. You need to sell the masks at a certain price. Anyway, let's continue. We passed these parts and I will delete them. Before going into the main topic, I also have today a specific part on math, which I got the impression for this topic is necessary. That part is on basically the relations. What is a relation? A relation is a way to connect numbers that are representing something to the numbers that are representing something else. In pure mathematical sense, those are numbers at different, let's say, at different planes. So you connect one number, for example, 1 in one plane, to the number in another plane, which is 1. The relation connects 2 with another number, a number with a different number in a different plane, in the second plane, which is 8. So 3 is likely connected with 27. So in this case, our relation connects 1 in the first plane to 1 in the second plane, 2 in the second plane to 8 in the second plane, 3 in the first plane to the 27 in the second plane. So 1, 2, 3 are in the first plane, 1, 8, 28 are in the second plane. So the relation is not on one of these lines. The relation is all of these lines. So our relation is a way to connect all numbers in the first plane to a number in the second plane. So it is not only one connection. It's not only this line. All these three lines are part of the relation we define. In practical sense, a relation might be like this. For example, one of those numbers might be, for example, age of a person. The other one might be the length of a person. I mean, the height, of the person. So in that case, for any age, our relation defines a height. Well, in reality, those relations might be right or wrong, but our relation is relating every age to a different height. For example, if we say those numbers might be taken from a real world. 1-year-old child is 30 inches. That's for United States, but let's keep the inches. 2 years of a child is 35 inches. 3 years of a child is old child is 38 inches. 4 years old child is 40 inches. Then our relation can be summarized like this. For the year 1, we are connected 1 in the age column to 30 in the height column, 2 to the 35, 3 to the 38, 4 to the 40. So looking to our table, for each age, we can find a height. So in this case, our relation is the whole table. This table as a whole, not only a row on the table. Okay. So this relation might represent reality or might not represent reality. But if we want to represent reality, we might use relation to basically show the information on height and age in a more organized way. We might also have sometimes formulas that represent a relation. For example, height is equal to 25 plus 5 times age is the relation. This is the relation, this part, height is equal to 25 plus 5 times age, is the relation itself. Because, let me do it in a let me open a page. Okay. Let me write here height is equal to 25 times plus 5 times h. And let me make this a larger so you can see. So using this equation, for any number that represents age, for example 1, we can find a height. In case of 1, it is 30. So this whole formula, and in the first row, is the relation in this case. The relation in the table is expressed in a formula. This relation in the formula can also be expressed in a table like this. When you look to how this table connects the ages to the heights, it's the same as the way this formula connects ages to the heights. So lastly, using the formula, we can also express age in a table. As you can see on this table, for any age, for example 1, you can go up and find a height. For age 2, you can go up and find a height. So this line basically also a way to represent age-height relation. So relations connect two different numbers in two different planes. I mean, which in real world might mean numbers that represents two different variables, two different variables, as I said, and they can be expressed in formulas, in graphs, in tables. We won't look to the formulas in this course. In more advanced economic classes, you also have demand and supply relations expressed in formulas. But in this course, we stick with tables and mostly, at least, with tables and the graphs mostly. Okay, at least at this stage in the second course, but mostly again we will in the micro part especially we will stay with these two things. Okay, so now we can start with the demand and supply model. So as a starting point, I should mention to make the concepts a little bit more clear. Demand and supply is representation of a good market. Good is actually taking its name from the literal adjective good. Good is something that is good for you. I mean, something that you might want to have. In the opposite one, bad, also exists in economic system. In that case, I mean, people pay money to sell their bats, for example, the trash, for example. They pay money to sell their trash. And there are sometimes also markets for bats, for example. Literally, in the United States, there is a company which is actually paid to take the nuclear waste of the nuclear power plants. I mean, the power plants pay them money to bury their nuclear waste because they do it more efficiently. I mean, alternatively, the nuclear power plants need to do the burying and isolation process of their waste. So, good, but that side we are not going into, although if you're interested, I can provide you some resources on bats. We are basically dealing with good, things that are good for the people. People want, at least some people want to have, the things that some people want to have. And they can be anything that is good, like cotton, which is tangible. Housing, which is kind of a bigger thing, which is kind of tangible but has more than tangible. It has more meaning. For example, the neighborhood where you live in is not represented by the shape of your house, like the case of cotton, where all characteristics of the cotton is in its material being, but not all characteristics of the housing is in its material being. And then you have things like education, which is by itself not tangible, physical, basically, which is also a good, by the way. Different names can also be used, for example, products, but not all goods are products. Sometimes things are not, products can be sold. Sometimes, for example, kind of you can say sunshine is sold, or the sea ability to go to swim is sold by holiday resorts, which is not produced, the sea is not produced by them necessarily, those resorts. Only maybe the beach might be organized, but not the sea, although sea is part of the products that is sold, part of the, I mean, goods that are sold by the holiday resorts. And in addition to, so not all goods are products. And sometimes commodity is used for goods that are sold and bought, because some goods are not also sold. Sunshine or clean air might be a good, but also not bought and sold. It might be available freely, or it might not be available at all. For example, you might want to go to another planet. That's a good for you, but you cannot find a way to do that, and no one is selling that as a service. Anyway, let's continue in the next part. See you in the next part.